Bismillahirrahmanirrahim. I am Said Adewale Latif, and I'll be taking you through chemistry. Today's class is gonna be on a simple basic concept that we know from SS1 chemistry, which is elements, compounds, and mixtures. As we all know, there are many substances in the universe, ranging from simple to complex, and each of these substances are actually made up of small particles that are built up to become complex. It is hoped that after today's lecture, students should be able to define elements, compounds, as well as mixtures. They should also be able to differentiate between them and give clear examples of each of them. Not that alone, students should be able to define purity of a substance and identify the criteria for determining the purity of a substance. Then they should be able to mention the various methods of separating mixtures. Let's start from elements. Elements can be defined as a substance consisting of atoms that have the same number of protons. Number of protons means the same atomic number. The atoms that make up that element, they must be identical based on the number of protons. In other words, for us to be able to call a substance an element, if it contains atoms A, all the atoms that make up that element, they must be A. There must not be a mixture of A and B. There must not be C. There must not be any other elements. There must not be any other atoms, in it. Elements are chemically the simplest substances, and hence cannot be broken down into its constituents by any chemical methods. What we are saying by this point is that although they are the simplest substances, but all the chemical methods that are available cannot be used to break down elements, even though we want to break them down. What are the chemical methods that we have? Like electrolysis, chemical reduction, chemical oxidation, and so on and so forth. If a particular substance is referred to as element, all these chemical methods must not be used and cannot be used to separate them into constituents. Although elements can be changed to other elements using nuclear methods, we shall visit that later by the grace of God. Example is in the case of uranium, that form thorium and helium. We can have protactinium and some other atomic nuclear elements like that. They are unstable and they can be used. They can cause harms, and they can change from one form to another using various processes. That is not where we are going today. Although atoms of elements must have the same number of protons, they can have different number of neutrons and hence different masses. Yes. In addition to the point that we said in number 1 point, that the atoms of an element must contain the same number of protons. But that doesn't mean that they can have different masses. They can have it, and the phenomenon is what we call isotopy. We shall visit that one also later. Examples of elements are iron, copper, aluminium, phosphorus, lithium, beryllium, neon, and so on and so forth like that. Currently, there are almost 118 elements that we have, although some are not yet named. But on record, we have 118 elements. So each of them, they are called elements because the atoms that contain each of them. Let's take iron as an example now. The atoms that make up elements, all of them, they have iron atoms. There must not be element of copper inside. There must not be aluminum atoms inside. That is why we call them iron. The same thing goes for copper, aluminum, hydrogen, beryllium, boron, nitrogen, and so on and so forth. When we have two or more elements that combine together chemically, it is what we call a compound. A compound are substances formed when two or more elements combine together chemically. There might be the same element or there might be different elements. They cannot be separated by any method except chemical means. It is only the chemical means that can be used to separate compounds. You cannot separate them by physical methods. As we cannot use chemical method to separate elements, we cannot use chemical methods to separate compounds. Examples are water. Water contains hydrogen and oxygen chemically combined together. There's nobody that can say, I want to tear hydrogen and oxygen apart by using force, any physical method, maybe by sieving or by heating or by any other physical methods. It is not possible. It is only the chemical methods that can be used to separate hydrogen and oxygen if need be. Common salt, iron oxide, copper oxide, copper sulfate, calcium carbonate, all these that contain various elements combined together chemically, they are what is called compound. Mixtures. Mixture is directly opposite of compound. When you have two or more substances that mix together physically, we refer to them as mixtures. Mixtures are the same as the name implies, mixture. We mix them together physically. It's what anybody can do, and we have been doing it. If somebody wants to drink tea, you can add sugar, milk, tea, and water together. These are called mixtures. No chemical reaction is involved in the formation of mixture. It is just physical means you can decide to add anything together to form mixture. Hence, mixture can be separated by physical means because the physical method is what is used to form them. We can also separate them by physical methods. So examples of mixtures are sugar and sand. Sugar can mix with sand and iron filings, shampoo, and so on and so forth like that. This will now take us to what is called homogeneous mixture. What are homogeneous mixture? There are some mixtures whose composition are known and the properties are uniform in the mixture. These are called homogeneous mixture. Examples are blood. Blood contains blood plasma, blood platelets, red blood cell, and white blood cell with fixed amount of each of the components. At any point in time, the composition of each of the components of blood, they are constant. The same thing here. Here is a mixture of gases: nitrogen, oxygen, carbon dioxide, inert gases like argon. We have water vapor there in the atmosphere. So it is established that air contains nitrogen, 79%. So there is no any instance that the nitrogen in the air is less than 79%. That is what we mean by composition are known and properties are uniform in the mixture. Heterogeneous mixture is directly opposite of homogeneous mixture. The properties may vary and the constituents may not be known. So let me give you 1 minute to think about these self-assessment questions, and we'll come back after applying the principles. Okay. Petroleum is a mixture because it contains a mixture of hydrocarbons. We shall see that one later. Bronze is also a mixture of copper and tin. It's a mixture. Epsom salt, I think it's a sort of magnesium carbonate heptahydrate, magnesium sulfate, heptahydrate. So magnesium reacting with sulfate, then some element water of crystallization is there, so it's a compound. Rubber latex, I hope we have all seen gloves that they use in laboratories and hospitals. So it is made of rubber latex and it's polymer, so polymer is a compound. Protactinium, I don't know if anybody has said that name in this class. Protactinium is elements in the actinide series. It's an element. So the exercise. So let's go through the following jump questions and apply the principles we have learned so far in this course. 1987 question 2. Question say which of the following substances is a mixture? A granulated water. I ask myself, can there be granulated water? Granulated? No. Water is water, and water is a compound, not a mixture. Seawater contains salt and water, dissolved salt in water. Sodium chloride contains sodium and chlorine, react together. Ion filings, this option is a tempting option. Ion filings, had it been they said ion filing and something, now we would have said it's a mixture, but ion filing is just ordinary ion, and ion is an element. So option A, we have a compound. Option C, we have compound. Option D, we have element. So it's only option B that we have as a mixture. Which of the following is not a homogeneous mixture? Don't forget what we said about homogeneous mixture. A mixture that has the composition uniform and the properties are uniform at every point in time. A filtered seawater. Filtered seawater, they have filtered it, they have removed all other impurities that are inside, and every other thing that remains, I believe the properties will be uniform. Soft drink, flood water, writing ink, all these things, only flood water that you cannot predict the properties because it is just flooding, it's erosion. You can have many things can be carried here. The upper level of erosion, maybe erosion is coming from a particular place. Now it carries many things, it draws many things along the way. So at every point in time, at every point, you cannot say this is what water contains. So the properties varies, the composition varies. Which of the following substances is a mixture? Question 2, JAB 1993. Is a mixture. We have sulfur, powder, bronze, distilled water, and ethanol. I believe sulfur, we know is an element. Distilled water is water, so it's a compound. Ethanol is a compound, so it's only bronze that contains a mixture of copper and tin. That is mixture. Call it alloy. Which of the following compounds is composed of aluminium, silicon, oxygen, and hydrogen? Year 2000, question 3. We have talked about Epsom salt, magnesium sulfate, heptahydrate, limestone contain calcium carbonate, urea contain nitrogen, carbon, and hydrogen. It is only clay that has aluminium, silicon, oxygen, and hydrogen. So let's go to other concept of purity. Somebody can ask, or I can ask myself, what is a pure substance? In the beaker 1 we have water molecule. In the beaker 2 we have water molecule and some particles. In the beaker 3 we have water molecule and some particles. 3 students, each of them holding each of the beakers. Which one of them has a pure substance inside? Beaker 1 contains only water, nothing else. Beaker 2 contains water, some things are inside. Beaker 3 contains water and some harmful substances are inside. I can tell you that it is only beaker 1 that is 100% pure, simply because it does not contain any other substance. Pure substance. Pure substance. Beaker 2 contains water, particles, and every other molecules. Beaker 3 is the same thing. So beaker 2 and 3, they are not 100% pure, although many things are not 100% pure in this universe, in this world that we are in. Like we have rainwater now. Rainwater can contain water and some dissolved salt. Tap water can contain pure water molecules and some dissolved ions. Distilled water is more purer than tap water. Then the ionized water is more. That is when you have removed all the ions. That is what is called 100% pure water. And again, the concept of impurity doesn't mean that something is poisonous. As we will see later, impurity does not mean that something is poisonous. Pure substances has no particle of other substances in it. That is just the basic concept of something being pure or not pure. Has no particle of any other substances in it. So if there is particle of any other substance in it, whether it is good or not, we refer to that substance as being impure. Any substance that has, in addition to its particles, is said to be impure. If any substance has any other particle apart from its particle, so that substance is not pure. Example is water that contains calcium and magnesium ions. That water is impure, although calcium and magnesium ions are very useful to our body. They are not harmful, but for the fact that they are contained in addition to water particles, that water is said to be an impure water. Not all impurity are bad, and some are beneficial to the body, like the calcium and magnesium example that we said earlier. Does purity matter? That is a question we need to ask ourselves. Why? Why must something be pure or impure? Why do we have to worry ourselves about purity? Now, purity matters especially in analytical exams, like let's say in preparation of drugs, in medicine, in pharmacies, even sometimes in adding flavors to food. Purity is important, because in drugs it is something that somebody will take inside his body, and life has no duplicate. Nobody will joke with his life and In that case, anything that wants to enter the body has to be very pure. That is it. Any unwanted substances mixed with desired substances is called an impurity. Sometimes it don't matter whether something is pure or not. Like we want to bath, we want to wash our clothes now. It doesn't matter whether the water contains calcium, magnesium, or contains some element of death, because the usefulness is not that analytical. We don't really need pure substance for that. So any substance that has any other thing apart from the size of that impurity, let's assume now that a student A has water and salt is inside, student B has water and sugar is inside. So if I ask you now, which of them has pure water? I know somebody will believe me that the two of them has no pure water, because the water contains elements of other substances that we don't want. If actually water is what we want, the sugar and the salt that are contained, they are impurity. Although sugar and salt, they are not bad, but in this particular context, we don't need them. Let's assume we want to make tea and sugar now mistakenly pour into our water. Can we use that water for making tea? No. So in that case, the water is impure because of the salt element that is inside. So if we want to produce, let's say we want to make something like, we want to apply water, use water to cook now, and in it we have sugar inside. Although sugar is not bad, but in that context we don't need sugar to be inside that water. Technically, a pure substance has a definite shape, is a definite and sharp melting point. Definite and sharp melting point and boiling point, and these are different for each substances. Water, a pure water has its own melting point and boiling point. Naphthalene has its own. The table below shows it. Aluminium has its own melting point. Like that, there are many substances that have their own like that. If a substance contains impurities, it causes drop in melting point and rise in boiling point. So also, it boils and melts at a range of temperature, not at a particular temperature. What we are seeing is this: if a particular substance is pure and the boiling point is, let's say, 25 degrees now, for that pure substance, any time that the temperature increases to 25, it must boil. If it doesn't boil at 25, that means it contains impurities. The more the impurities, the higher the rise or fall in boiling point and melting point respectively, and the wider the range. Consider the table below now. We have water that melts at 100 and boils melts at 0 degrees Celsius and boils at 100 degrees Celsius. At exactly 100, pure water will boil. At exactly 0 degrees, pure ice will melt. So if that ice now contains element of impurities, any temperature below 100, that is when the water will boil. Let's say 1, minus 1, minus 2, minus 3, like that, below, and it will not boil at a particular temperature. Maybe some will boil at -5, some at -4, some at -8, like that. The same thing for boiling point. Instead of the water, the pure water to boil at 100, it will not boil at 100, it will boil at, let's say, 101, 105, 110. And the boiling point must definitely be higher than the normal boiling point of pure water. The same thing goes for sulfur, like that, and any other substance that contains impurities. This is the end of the class. Let's now apply the concept to this damn question. 1989 question 1. Which of the following will support that a substance is a mixture? The solid can be ground to fine powder. Does that even reasonable to the concept of mixture we talk about? I guess no. The density of the solid is 2250 kg per meter cube. No, the density is not a criteria for mixture. Solid has a melting point range of 300 degrees Celsius to 325 degrees Celsius. It sounds reasonable. The solid of the mixture from the atmosphere. I think that option is not even correct. The solid of the mixture from the atmosphere. The mixture from the atmosphere. The solid of it. Is it a mixture? No. So C is the only answer. It's the answer to this question, because according to what we said about pure and impure substance, any substance where the boiling point or the melting point has ranges, not a particular point temperature, that is contains another substance, that is a mixture of two or more substances. So that concept answers this question. The melting point range from 300 to 325. So far it is not a single temperature, it is not a particular temperature, let's say 300, so the substance is not pure, so it's a mixture. So this is the end of the class for today. We meet the other time. Thanks for listening.